Yesterday, I was able to show you real quick. I had you drop your pencils and just listen, just focus, all right? How many different symmetries am I testing for? 3. I circled 3 things in each of these symmetries. Now, question, don't all of these 3 have functions with a normal point? Yeah, all functions have an xy. So the xy is what's normally there. I see an xy, I see an xy, and I see an xy. But here's what comes after. It says, okay, start with xy, start with the normal equation, and then test for x negative y. So then look at my next equation. For x-axis symmetry, you try plugging in x negative y. So for x, well, plug in x, it stays the same. But for y, plug in negative y. And then how do you test? You simplify and say, is it the same? If it is the same, then this point is on the graph as well, and I say check. X-axis symmetry, true. Now wait. For the y-axis symmetry, you test this point. Now I did in this equation, but let's go back for just 1 second. What if we were to test this function for y-axis symmetry? You don't have to write this down, it's going to get messy in the notes, but just follow along for me just for a second, okay? If I were to take y squared equals x and plug in this point as well, y would stay the same, and what would happen to the x? Simplify. I could multiply both sides by a -1, but then the negative's over here. Long story short, is it the same? This function does not have y-axis symmetry because you plug in the point and simplify, and it's different. It's not the same. It doesn't stay true with the original function equation. So each of these tests encapsulate plugging in each of these points. So then check out what happens in the function that does have y-axis symmetry. The example I gave, y equals x squared. I plugged in negative x for x. Remember, always plug in with parentheses. That's just a quick little tidbit. You should have learned in Algebra 1, Algebra 2, but sometimes we forget. Plug in negative x for x. Plug in y, well, it stays the same. And negative times a negative is a, it matches. So y equals x squared has y-axis symmetry because the test worked. And last but not least, origin symmetry. You plug in both a negative x and a negative y into my function. Plugging in a negative y, plugging in a negative x. Simplify. What's a negative times a negative times a negative? Because 2 of them make a positive, and then you have a negative left over. So I ended up with a green mark on there. The negative on the y is still there. The negative is on the x cubed. I can multiply or divide by a -1. It comes out to be the same. Check. So if I was to give you this one, okay, I have this in the notes just because the book has this whole huge table. It's like 3 different points. There's like, I don't know, 3 massive sentences. I guess it's not more than 3 sentences, but they're huge. But you could memorize, you could study, you could write down in your notes if you want. It's up to you. I'm trying to simplify things a little bit. That's what teachers try to do. Make it more understandable. So let's go and just try to use the 3 tests that I just showed you. For each test, there's something to plug in, and then simplify, and then check. We're going to go in the exact same order as I did in the notes, just to keep it nice and clear. We're going to check for x-axis symmetry. We're going to check for y-axis symmetry. And then we're going to check for origin symmetry. And I think if I'm right, this is kind of like the directions for those ones that you were asking about, right?
Yeah.
Perfect. This is ultimately what you're supposed to be doing in those ones in the 40s. And as you get more familiar, it might get a little bit easier and a little bit faster to tell which ones to test for. Some of you are already going, that's perfect. You know what's going on. Some of you are like, I'm just following you. Cool. For x-axis symmetry, what special point needs to work? X and negative y, right? Plug in and simplify. For y-axis symmetry, what point needs to work? The x is negative, the y is positive. Plug in and simplify. And then for origin, they're both negative. Take a second. You try to plug in. Let's see how it goes. We'll check it out in a bit. Hopefully this will help on those 40s ones. That we were just like, symmetry. And I told you, calculus kids hate symmetry too. It's not just you. The fact that you haven't done tons of review on it, it's just hard. Not know just because you guys figured out this is from the book. It's not bad. It's not the way I would do it. Alright, real quick before we talk about it. You guys check in your groups just because maybe sometimes you can help each other better than even I can help you. I'll show you the answer, but talk it out just a little bit. What have you tried, and does it match up with what your group has done? Quickly group together. Take your competition books and turn.
I got the second y-axis.
Yeah, I got y-axis.
So one connection with all the ones that are negative.
This side. This side. This side. Very, very high.
Why the Z axis?
I had it.
Okay, pause. Check your first step. I haven't simplified anything. Alright, groups, go ahead and focus back on this way. Just check your first step. Just check your first step. Did you plug in the points right? Plug in x for x, well, it stays the same. Plug in negative y for y. Guys, can we simplify our way out of this?
No.
We can move the negative, but then it flips the signs. It's not the same. So therefore, I can say x-axis symmetry. It's not working. Now, check out the next one. Can I simplify this one? A negative squared is. And then check it. Are we good? Oh yeah, y-axis, that's a check. And then last but not least, origin. Well, we can simplify. I'm going to put a little arrow because I'm going to rewrite the whole thing. I have a negative y now equals, struggle guys, is it the same? Y-axis symmetry is the only one that works. Questions? How do we test for symmetry? Plug in those particular points and then test. And it will have the symmetry if you can simplify and it remains the same as the original. If it's different, messed up in any way, shape, or form, we're done. There was one more piece of notes. We did talk about symmetries yesterday, but this is what the last 4 problems, besides the word problem, the last 3 problems, were about. And you guys could see in the direction, circle, circle, and I said just stop at the circles. Standard form equation of the circle. It's one that you've seen for a while now. I need to keep this open. Geometry's coming back. Just a little bit. No. No. If I did do proofs, they'd look a lot different than geometry ones. They are good. They're the basis as to why we can do it. I actually like to call them proofs. Anybody with me?
No.
I like them. I tried. I don't like all the memorizing of formulas and the secant lines and the inscribed, circumscribed. But alternate interior angles, solving for like, I don't know. Oh, that was okay. Like the x's, you have to like figure out the something. All right, come on back in. Question: who remembers what the HK is for? It's kind of important.
Y equals KX.
You got this one.
Nailed it.
The H goes with an X, the K goes with a Y, and the special point, 1 point of a circle is the,
Center.
no. Now, some of the ones you guys are going to see in homework, if you didn't keep going, which is totally fine, do give you easy information like, in this example, it says example 8, it's directly the 8th example in this section of notes. Remember, or sorry, in the section of your book. You guys count through. How many pages of notes have we taken on 1, 2?
2.
2. If you write really big, maybe 4. Anyway, how many pages in the book did I condense from? 1, 2, 3, 4, 5, 6, 7, 8.
Wow.
Now wait. Nice. Okay, no, pause. Is there more in here than I'm going to ever give you? Look, yeah, your composition book's a bit smaller. I'm summarizing. I'm doing the key points. I'm trying to give you little tricks to the trade along the way. Okay? But there's a lot more here. So if you ever get into homework and you're like, it's not in my notes, where should you look first? Yeah? Come back. Some people are wondering why it says example 8. Anyway, that's fine. What's something I could plug into the formula from the get-go from this illustration of the circle? I can't plug in 3, 4 yet. What can I plug in? This one. Does that make sense? Okay. Now I can see the radius. You guys, if you were in geometry, could label the radius. Right? It's right there. I got it. Like, focus. Okay. What do I put into the x spot? What's the x coordinate of the center? -1. Careful of those minus and negatives. Y minus, what's the y coordinate of the center? 2. Now hold on, what am I missing? The radius. What else do I have? 3, 4. Now Ricky, that's totally one way. That's probably where most people's brains would go. I need that distance. I have 2 points. Distance formula. Can anybody think of another way? I'm not saying one way is easier than the other. I did distance formula with honors. I have.
I guess you use the other points as the y values.
You could plug in 3 and plug in 4 and solve for r. Depends on what you like. Do you like to plug into a formula and find distance? Then do that. Very like, I can just plug in and solve. You could plug in 3, which is an x, and 4, which is another x, and you could solve for r that way. Okay? Now, technically, because I like the distance formula, because I think of it visually, I'm going to go that way. I think it's easier. But it's up to you guys. You could have plugged in that xy. I just want to show you. Remember, not every problem has only one approach. Some honestly do. But many problems have many different approaches, and as long as they're legal, you have the freedom to take different approaches to solve them. Now, here's what I'm going to do. I'm going to take my logical approach to the distance formula. But that's just me. And I'm going to say this one hits at -1. I'm going to go by 1 because this whole going by 2s thing not working out. And I'm going to say, how long is it? 1, 2, 3, 4. How tall is it? 1, 2. 1, 2, right? Hold on. 4 and 2. Right? How do I find the hypotenuse? Square root of 4 squared plus 2 squared. Oh. Now, is that what the distance formula would have gotten you also? Yeah. 16 plus 4. Is that ugly if I want r squared?
Yes.
Is there a formula for r squared? Which would have actually worked out if we'd done it the other way as well. Just would have taken a little more work. What's r squared? You don't need the square root. You're just plugging it in. But either way, if you had had root 20, you could have squared it when you plugged it in. We end up with x plus 1, y minus a negative. Quantity squared minus y minus 2, quantity squared equals dun, 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 dun. Dun, dun. Okay. Now, some of the ones in your homework, quick heads up, they're a lot easier. Some of them. You only have 3 technically of circles, 1, 2, 3. 2 of them give you clues, 1 of them gives you an equation, and you pull out the clues. The 2 clues, one is easy, center, radius, plug in. The other one is kind of more like this one. You gotta think a little bit. Maybe I gave you an odd. Ugh, maybe it doesn't match up with the back of the book though. Draw a picture. But anyway, we're not talking about the last 4 problems. That's for you guys this weekend. Let's get Bristol underneath, spiral goes out. Sound good? Okay. Let's start at the beginning. And to be honest, guys, the back of the book was great for a little while. Up until 41, and then don't ask me, I don't know. They messed up. Let's start off at the very beginning. The odds were okay, I believe, up until 42, and then, well, that's the even, but up until 43, I think they got all messed up. But if you noticed a problem earlier, please let me know. Just, I didn't notice a problem until the 40s, but maybe I missed one. Number 4, the answer should be y-axis. That was the clue they gave you. Number 6, tables, that's numerical. That's numerical. Number 14.
Yes, number 1, too. Number 1 was solution 1.
Go in the back of my book.
Oh, yeah.
Okay, great. Hold on. Number 14. Letter A is a yes, letter B is a no. Why? Letter A had a true statement, and letter B had a false statement. So 4A is yes, it's a solution, and 4B is no, it is not. Sorry, 14. Number 22. Does this one match up okay with what we had? Remember, I told you there were some mistakes. 22, our x-intercept, 4, 0. Oh, we're good. Y-intercepts, there are 2 of them. 0 plus or minus 2. You could have also written 0, 2, and 0, negative 2. Totally fine. Number 42, my solution manual is wrong. But hold on, he's not that bad. Number 42, you should have had a graph. And I think it's shifted, is it over 3? 4? What kind of symmetry does it say it should display? Doesn't yet. X-axis symmetry. Can someone just quickly, in your own words, like not even with a definition or a point or something weird, what does that look like if it has x-axis symmetry? It is going to be a sideways parabola, but how do you kind of come to that conclusion? Does that make sense? X-axis is over the x-axis as though you're folding it down and copying it, so it's going to be, just finish it. Just finish it. Folding over, okay? Folding over. Number 40, what did I just say? I have no idea. Okay. Number 43, it's another graph. I can't remember what this one looks like. It's a little more twisty. Yeah, it's a little more twisty. What kind of symmetry is this one supposed to display? Origin? I don't know. I think it's a little bit harder. Maybe not. If it was x-axis symmetry, this would fold down, and that would fold up. It would be reflected across. If it was y-axis symmetry, it'd be a W. You guys see it? If it's origin, it folds over and down. Which means instead of being in quadrant 4, it's going to be in quadrant 2. Instead of being in quadrant 1, it's going to be 2 quadrants over. There we go. Some of you are very visual and you're like, oh, I get the whole folding thing. Some of you are like, that one's hard. It is. It's a little bit hard. harder right around the 40, where did it start? You okay? You good? It was rough. Starting with 45, it got a little rough. A little bit harder. 48, you were supposed to find intercepts and symmetries. Testing each of the points like we saw today in class, guys, none of them would have stayed the same. All of them would have changed something that you couldn't undo. So no symmetries. And if you look at the graph, it kind of makes sense too. Without going into what we're going to be reviewing in a little bit with the whole downward parabolas, there's no symmetry here. There's symmetry about the axis of symmetry, but not the x or the y or the origin. And then what would have been my quick clue as to how to start the x-intercept part? What's that one thing we always have to remember when setting equal to 0? If you didn't factor, it's going to mess everything up. Remember, next one, I think I'm showing odds too at this point, because remember the odds were off. We have an odd number. Remember 51 is the next one? Remember the odds were off, so you need to check your odds at this point too. 51, check it real fast. Oh, thank you. Now they gave a table because they didn't think you'd be able to graphics. It was a little too confusing. They didn't necessarily state that you had to do a table. Can anybody tell me real quick, why was the y-intercept none? What happened when you tried to find it?
Oh, it was a negative in the.
A negative and a square root, it was imaginary. That doesn't work out so hot. But looking at the graph, you're like, oh yeah, we'll never hit the y-axis. Number 55. He does have x-axis symmetry. Plug in a negative y, it goes away. Where are we going after number 55? 65, 71, 74. Okay, to be honest, I need you guys to help me out as to whether or not, this is you guys with Calc Chat, whether or not the next answers measure up. I'm going to 65, right? Here's the solution manual. Should be perfect, but is it? Does number 65 answer your question?
No.
Not even close. So let's go back. Number 65 is asking for x square root of x plus 6. There he is, you see him? Does that look better? You're allowed to use your graphing utility that's like, I don't know, music to your ears, right? And approximate any intercepts. Not too bad. What's number next one? 71, 74, 75.
I didn't do those.
Did they get tricky?
Circles.
Ah, so maybe we need to. Let's check it out if they're right though. I don't think they are. Is that right? Nope, not even close. But it is a circly one so they can stop because remember I wasn't necessarily requiring those. I'll have those ready on Monday for you, but then we can go ahead and stop because we weren't necessarily getting at the circles. Anyhow. Okay. Homework number 2, section 1.2. Thanks for hanging in there with the whole weird back of the book craziness. Let's go ahead and get into section 1.3. Oh, come on. We can't delay it another day. And guess what 1.3 is on?
Circles.
Good guess. Circles are a little more complicated than we want to go right around. Section 1.1 was introducing like everything with points. Section 1.2 was introducing graphs. Section 1.3 says let's start getting into detail. Section 1.3 is going to say let's start getting specific with lines. Lines. Shouldn't be bad yet, right? But as you guys are noticing in the review, are there some kind of tricky things here and there? Yeah. So let's enjoy the easy stuff and let's power through the, and hopefully get a better grasp on the other stuff. Now hold on, why did I have this page right before? I'm reminding you, table of contents, you gotta start a new section. But why am I just leaving everything blank now? You guys should be able to look at the notes and say, oh sweet, table of contents 1.3. Put in a quick summary of the title. Page number, remember, wherever you last stopped writing for section 1.2, that's not the same page of 1.3, it has to be the next page. Okay, start at the top. It could be on the back or it could be just right beside. Start at the top. You guys good? Okay, I'm not going to show you table of contents stuff ever again unless I realize you're doing it all wrong. But hopefully we're good. As you guys are starting, let me give you just a few things and let's see if you remember, just to fill in. I'll move, give me 1 second. So you guys know my lines to skip, and also if you know it, fill it in. Let's test it and see if we're good. I'll stop there. Can we go to the college fair tomorrow?
Busy.
It sounds like a really cool opportunity. I know that you're probably like, it's my Saturday. First of all, if you have an RSVP, just stop here. But for those of you that did RSVP, sounds like a cool opportunity. 3 different schools, tons of kids, and tons of counselors just wanting to help from different colleges. All right, you guys ready? Let's do this linear equation thing. So, slope-intercept, come on. Shout it out. Y equals
X plus B.
mx plus b. Where, if you want to label it, if you need to label it, please do so. What's m?
Slope.
Slope. What's b?
Y-intercept.
Y-intercept, the point at which, or the height at which the line crosses the y-axis. Point slope.
Y minus Y1.
Y minus y1
X minus M
Something.
times X minus X.
What's m?
Slope
What's x1, y1?
points.
Any point. So wait, what makes point slope more generally applicable than slope intercept? Any point. And it could give you 2 different points from which you would have to find the slope. We'll get there. Standard form, the one that is my least favorite, but still shows up every now and then.
No way.
It's that one. Ax plus,
Oh.
this is like an algebra 1 thing. I don't know why they write it that way, it just happens. Even like on the AP calculus test, sometimes they give you a line like that and you're like, really? It's okay. Standard form, can you see m?
No.
Can you see a point?
No.
So what do you have to do? Get y by it. Okay, special slopes, horizontal. Okay, we know what a horizontal line is, right? Remember real quick, horizontal line. Which axis has horizontal tick marks? Right? Has horizontal tick marks. That's my silly way of remembering. Or if you took Shanks, y can fly. Anyway. I'm just going to say some number. Y equals constant c. Not like a c up above, a little c, just y equals a constant. Y equals a number, it's a horizontal line. How does that make sense? Fit it into slope-intercept form. If y only has, focus, a constant. Notes are going? Pencils going? If y equals a constant, what's missing? Look at slope-intercept, what's missing? The slope. Well, the slope's not missing, the x is missing. And what made the x go missing? A slope of, This would be cross-country skiing. Well, I don't know. It'd be boring skiing because you're just walking, right? You want a slope if you're skiing, if you're snowboarding, right? If it's like this, not interesting at all. If it's like this, you're dead, so it's even worse. So, hold on, vertical, let's talk about it. tick marks, vertical on the x-axis, right? So it's going to be x equals a constant. I'll just name it something else. Think about it. M is 0? No, that's boring, right? No fun. This one? Too much fun. Undefined. Just kidding, not fun at all. But if you guys want to dig just a little deeper, maybe you haven't heard this before, it's actually infinite slope. That's fun. Actually, it has to do with limits, which is kind of calculus, which is the last chapter of the book, so I can't go in much more detail unless you want to come in and ask me. But technically, a vertical line is infinite fun, but you're dead, and then you're with God, and then He's infinite. We'll just say that. Okay, so, hopefully, equation for slope, M equals.
MX, no, that's not.
No, don't do
equals
that.
YX plus.
Nope.
M equals Y2.
Let's go old school.
Oh, rise over run.
You have to? Yeah, that's what I was looking for. Old school, rise over run. What else? Hey, from our graphing calculator, since you guys never saw it before, supposedly, let me show you the technical. Delta y over delta x. What does delta mean? Graphing calculator. Change in. Change in. How do you figure out the change from one quantity to the next? Subtract. You count, or you subtract. Random. Scientific studies have actually discovered that kids that learn how to count, do finger math, end up more successful than those who don't. Random. Anyway, maybe we'll watch that video sometime. TED Talk. Right. So much smart stuff. Although some of them are a little crazy. Keep going. Good? Sweet. I have fast writers this year. Remember, if I go too fast, you know where to find it. Parallel and perpendicular. If we're talking about slope, you gotta go there. Focus back on it. I agree. Oh. Okay, so. Parallel, perpendicular. You're pondering, but I don't know what. Parallel, perpendicular. Come on, remember from geometry, parallel means two lines that never intersect and are in, let's be geometric, the same plane. Remember, they could be skewed. That's not parallel. Has to be in the same plane, the same sheet of paper can connect. And have the same, sorry, I said it, we never wrote it, the same. So if you're supposed to, for instance, in the example down below, figure out a line that is parallel to. You've got to figure out its slope and then keep it the same. Perpendicular. Remind me, geometry, what's going on?
Always crossing 490.
Crossing at a 90-degree angle, we can say that. Intersecting at a 90-degree angle, we can say that too. Technically, if you think about it, we could do the little like, anyway. What kind of slope? Oh, come on. Sounds make it interesting. Opposite? Reciprocal. Two things have to change. Opposite means what in math? Negative. Oh. Negative to positive or positive to negative. The other sign, right? Opposite means the other sign. And reciprocal means 2 becomes over 1, 1/2. 3/4 becomes 4/3. 1/2 becomes 2. Opposite, reciprocal, slope. Yeah? Now, when we get down below, when we actually have to solve for a parallel and a perpendicular line, what is the clue? They give us 2. What are the clues they give us? The point. So the lines need to contain the point. Focus. 2, 1. And it gives me a whole nother line that I need to use. Now, this whole nother line, it's in standard form. That's gross. Okay, let's make it in slope-intercept form. Life is better. For sake of time, can I do the math fast? We're going to subtract the 2x. Negative 2x plus 5, divide the negative 3. That ends up with a positive 2/3 x minus 5/3. Now, you could have done that. You might have just taken a little bit longer in showing the steps, which is important. It's better to get it right and take a little longer. It goes too fast and get it wrong. So what is the M of the line that we are trying to make our new line parallel and perpendicular to? 2/3. Now the nice thing about point slope says, hey, just plug in and go. So for parallel, What do we do with that slope? Keep it. For parallel, keep it. Exact same. Plug in the point. That's an x-coordinate. Plug it in there. That's a y-coordinate. Now, should you be able to distribute and move to one side and make it all nice and pretty and slope intersecting? That's a word. It's not. Yes. But what do we do? Just, this is the idea for perpendicular. Start the exact same way. Ah, let's not put it in the M. We can actually find that puppy. What do I do with that 2/3? 3/2 and make it negative. Plug in that point just like we did before, and I have full confidence that step by step we can move it all to one side, get y alone, and simplify. Oh man, this is crazy. Guys, we have a whole minute. I don't think we can finish. Oh wait, we're done. What's section 1.3? Linear equation. Everybody heads up. How much really should be left of homework number 2? 4 problems.
40 problems.
And how hard is homework number 3?
Incredibly hard.
Let's do it.
Now hold on. Some of you have noticed there is a Google Classroom assignment for sake of time. We'll talk about it Monday. No stress. Google Classroom, just ignore, okay? However, do the 4 problems of number 2, and if you slacked last night and didn't do the rest, real hard again. But otherwise, do 4 problems and do some lines and you're good. Homework number 2, homework number 3. Sound good?
Yeah.
Cool kids?
How do you answer the purple question? It's 50. No, but then that's 50. We gave the answer.
It is technically 50 because there are 2
Let's
choices
go.
of the right
That's
answer.
fine. Yeah. I said 52. Then I
So
realized
2 out of 4 would be right.
yeah.
But your first inclination is
Is to say 25, but there's 225.
Somebody left their copy of The Shallows under my desk.
Oh,
so
no.
I'm just going to choose to ignore that it's there. Because
you tried to state it and it was too late. It's
yeah,
okay.
I'm not named Pete.
Let's do it.